Hello and welcome to SAS video tutorial. Today we will be talking about producing detailed reports. Here first we will be talking about subsetting report data. Our objectives would be to create a default proc print report. We will select variables with a var statement. We will calculate totals with a sum statement. We will select observations with a where statement and define a date constant. We will also identify observations with an ID statement. First, print procedure. By default, proc print displays all observations, all variables and an OBS column on the left side. So the program reads like proc print data equals to orient.sales, and then we have the run statement, and that is what our partial proc print would look like. Statements and options can be added to the print procedure to modify the default behavior. The var statement selects variable to include the report and specify their order. So if we see the output, we have last name, then first name, and then salary. So that is the same order that we have mentioned in var statement, that is var, last underscore name, first underscore name, and the salary. The sum statement. It calculates and displays report totals for the requested numeric variables. So the program remains the same, we just add a sum statement. And here we are doing the sum for the variable named salary. And in the output, we can see that we have the sum of the salary variable, and which is a partial output. And when we view the log, it has read all the observations, that is 165 observations from the dataset orient.sales. The order of the statements in the SAS procedure is usually not important. OneStar management wants a report that displays the name and salaries of the sales employees earning less than $25,500, and we would like to suppress the OBS column. So we use a where statement to select the number of observations based on some criteria. So here where salary is less than 25,500, for them only we want to display the report. So when we run the previous program, we see that only 7 of the 165 observations from orient.sales was selected by the where statement, as we have put this criteria, and this is the partial output that we see. Suppressing the OBS column, as according to the scenario we do not need the OBS column to be appearing along with our report. So we use a no OBS option in the proc print statement to suppress the OBS column. As we can see in the proc print statement, at the end we have no OBS option that is already highlighted, and when we submit the following program, we get the following result that we can see at the bottom. Where statement. The where expression defines the condition or conditions for selecting observations. So operands are the variables or the constants or where the operation happens. Operators are responsible for the operations being performed. So operands are character constant, numeric constant, any date constant, character variables, or numeric variables. Where operators, symbols that represent a comparison, calculation, or logical operations. SAS functions, a special where operator. Operands, let's know them in detail. Constants are fixed values. Character values are enclosed in quotation mark and are case sensitive. Numeric variables do not use quotation mark or special characters. Variables must exist in input data set. SAS date constant. This seems to be confusing a lot of times, so you need to take care of this topic very carefully. A SAS date constant is a date written in the following form only. So that could be the date and then the first 3 abbreviation of the name of the month, and then the year value could be of 2-digit or 4-digit. We cannot use MMDDYY formats like the numbers one, like 010119 1960. Those formats will not be using. So date constant should always be DD MMM YY or YYYY. So SAS automatically converts a date constant to a date value. So this helps in comparison and making our calculations easy. So this should be like 01 Jan 2000 closed in single quotes followed by the letter D. So that is the syntax. Comparison operators. Comparison operators compare a variable with a value or with another variable. So the symbols that we have equal to, then we have mnemonics, and then the definition, what it means. So either you can use symbol or you can use mnemonics, whichever you find easy to use. So this is the list of the comparison operators that we have: equal to, not equal to, greater than, less than equal to, greater than equal to, and in option. So the examples that we have here are like where gender equals to missing, where salary not equal to missing because there is a period, where salary is greater than equal to 50,000, where hire date is before 1st January 2000, and we have used a date constant operator here, and then we used an in operator, that is where country in, where country in. The difference between both example is that we can either separate them by comma or we can separate them by a space. And if we are using a numeric variable or numeric constant, then if we are using a numeric variable, then we are not going to use the values in quotation mark. The value list in the in operator must be enclosed in parentheses and separated by either commas or blank. Character values must be enclosed in the quotation mark. Logical operators. Logical operators combine or modify where expression. So the logical operator here that we used is and in the example, but we can use and, or, not. These are the logical operators that we have. So the syntax is where, then the expression, any expression like country equals to AU, and or then the second where expression. And you can add multiple where expressions with these logical operators. When we submit the program, this is what we get. So out of 165 observations, we get only 51 observations where orient.sales were read, which has the value of the variable as AU and the value of the salary less than 30,000. Logical operator priorities. The logical operators can be written as symbol or mnemonics, and parentheses can be added to modify the order of the evaluation. So the priority, default priority, not gets executed first, then and then or. The not operator modifies the condition by finding the complement of the specified criteria, like where city not in London, Rome, Paris. So any city other than London, Rome, Paris, those data will be displayed in our report. So logical operators, where country not equal to AU and salary is greater than equal to 50,000, only those reports will be printed. So these are the following examples you can go through, and this will clear your understanding. Logical operators examples. Where country not equal to AU and salary is greater than equal to 50,000. Here the values, observations who has the country value as AU and salary greater than equal to 50,000 would be displayed. Similarly, we have different conditions here. There are two statements which means the same, like where country equals to AU or country equals to US. Again, we can write the same expression using an in operator, that is where country in AU or US. These both are equivalent expressions. We should use only one where statement in a step. Orient Star Management wants a report that lists only the Australian sales representative. So that means they don't want managers or any other profiles to be present. Only the sales representative should be the part of our report. So when we write a program like this, that is proc print data equals to orient.sales no ops where last name, first name, country, job title, and this should be our partial proc output. So we will not have chief sales officer as well, so that should be removed. So subsetting in a proc print step, include a where statement to subset by country and job title. So if we submit this program like proc print equals to orient.sales no obvious where last name, first name, country, job title, where country equals to AU and job title contains rep. So those are the representative for sales. So contains is a special where operator. We can remove the contains mnemonics with a symbol, that is a question mark. The contains operator selects observations that includes the specified substring. The question mark can be used instead of the mnemonics. The position of the substring within the variable's value is not important. Comparisons made with the contains operator are case sensitive. And when we view the output, this is what our partial output looks like. Special where operator. Special where operators are operators that can be used only in where expression. So contains, it includes a substring between and an inclusive range, so both the initial and the final value would be included. Argument, a where expression, so if we are using multiple where statements in a program, then this might be helpful, though it is not recommended. Is null, is missing is same, it would be just handling your missing values, like it matches a pattern. Between and operator, It selects observations in which the value of the variable falls within an inclusive range of values. So where salary between 50,000 and 100,000, where salary not between 50,000 and 100,000, so these both values will not be included then. Where last name between A and L, and where last name between Baker and Gomes. So this follows the dictionary pattern to find any values between A and L and Baker and Gomes. All these three statements are equivalent but could be written in three different ways. Where salary between 50,000 and 100,000, where salary is greater than equal to 50,000 and salary less than equal to 100,000, where 50,000 is smaller than equal to salary and salary is again less than equal to 100,000. Where same and operator. So if we are using multiple where statements, this is very much helpful. So it augments the where statement. Use the where statement operator to add more conditions to an existing where expression. The where and same condition arguments the original condition. And when we view the log in a note, we will see it says where clause has been augmented. And this would be our partial output. Is null operator. The is null operator selects observation in which a variable has a missing value, where employee ID is null and where employee ID is not null. Is null can be used for both character and numeric variables and is equivalent to the following statement, where employee ID equal to like a space in quotes that is missing for character, and for numeric we have used period. Same goes with the missing. So is missing and is null is same, exactly the same. Like operator, it selects observations by comparing the character values to a specified pattern. Two special characters are used to define a pattern. A percentage sign specifies that any number of characters can occupy that position. An underscore is that specifies exactly one character must occupy that position. So here, where name like percentage n, so any name that has the capital N at the end, or any variable or string that has the last letter as capital N, would be the answer to this where expression. And then when we see the next one, so names like Tom, Tim, Tam, those words would be appearing here because we have specified only one character come in between capital T and small m, and the total length would be 3. In the last option, where it starts with capital T, has one letter gap where it could be anything, and the third letter should be M, and then it can be followed by any number of characters. So that examples would be like Timmy, Tommy, Tammy, Tomato. So these names would be applicable here. The sales manager wants a report that includes only customers who are 21 years old, and we want it from orient.customers underscore dim dataset, and our criteria is customer's age equals to 21. So this we display the required rows and variables. So where customer's age equals to 21. The subsetting variable does not need to be included in the report. Viewing the output. In this output, 2 lines are used for each observation because this is the way it used to get displayed previously, like before the version 9.3 in the output window. But now as we have the HTML formats now, so the things does not get into multiple lines, it gets managed. The obvious columns help identify observations in a report that spans multiple lines. ID statement specifies the variable or variables to print at the beginning of each row instead of the observation number. So proc print data equals to orient.customers dim, where customer age equals to 21, ID customer ID. But we did not use this customer ID variable in var statements. When we see the output, we see that the customer ID has replaced the OBS column, and this is acting as an identifying column. So let's go ahead and submit the programs, where first we are going to print the normal data set, and when we run this, so we get the output as this one. We get everything, and let's see the log. So we have 165 observations there, and if we see our result, we have around 1 2 3 4 5 6 7 8 and 9. There are 9 variables that is present there, and we will go back to the same program and we will limit the number of variables by adding the where statement in our program. So to run a specific part of a program, we will select and then press F3, or you can click on the submit button. So now we have the less number of variables. Only those variable appears here whose name were given in the where statement along with the observations column. Now we want to do the sum of the variable named salary. So let's go ahead and run this program. So we use a sum statement with sum as a keyword, and then we are doing the sum of the variable salary. Let's go ahead and run this program as well. So when I execute this program, so if I scroll down to the bottom, I get a total that is 5141420. And if you want to see, did we get this total in our previous output? No. Look, this is the end of the previous output, previous result. We do not have any total at the end of that report. Now we will put some criteria to limit the number of observations. Earlier we limited the number of variables. Now we will limit the number of observations. So we put a criteria whose salary is less than 25,500. Let's go ahead and run this program, and we haven't used any option along with it. And when we run this program, we see we get only 7 observations with the 3 variables, because these are the variables we have specified in where statement, and these 7 data actually puts true. So these 7 are true, that these 7 data have salary less than, so these 7 people have salary less than 25,500. Rest of them have the salary more than this. Let's go ahead and run the second part, where we are using a no obs option. This will suppress the observation variable or the column. Let's press F3 and run this program. See, we don't have any observation column here, but in the previous output there was the observation column. Now we will be using multiple where conditions in one where statement. In where statement, we have given 2 criteria, like where country equals to AU and salary is smaller than 30,000. Let's go ahead and run this program. So his salary is less than 30,000. We have more people now. So let's see how many observations were printed. There were 51 people whose salary is less than 30,000 and who belong to Australia. Here, first let's go ahead and print the data for in sales without any observation, and then we will put the condition. So when we run this first program, so this is what we get. So if we check, we can see that we have other job titles apart from sales representative. So REP represent representatives. So we have senior sales manager, sales manager chief, and these titles would also be included in our data, but we want only the representatives data to be reported. So we go ahead and put a condition where country equals to AU and job title contains rep. So let's go ahead and run the second part. So now in this, we will not find any of those guys. At the end we got them right, the manager and the others job titles, but now they are not there because the criteria has been applied. Now here we have 2 where statements. Let's go ahead and check if both the where statements can work together, because we have studied that 2 where statements does not work. So we have the condition there where the employees are from Australia and salary is less than 30,000. Apart from that, one more condition, the gender has to be female. So let's see our result. Gender across the report we got female, and country AU, okay, country is Australia, that is perfectly fine. But salary is less than 30,000. Yes, everyone's salary is less than 30,000 because we have used same and option. So this is the importance of same and option along with where statement. So if we remove same and then execute this program, see what happens. Country AU is there, US country data is also present, though it has filtered the data according to the second criteria only, that is based on the gender. It did not filter according to the salary because we have some guys whose salary is more than 30,000 and they are from US. Here we are going to suppress the observation column and replace it with another identifying column that will be one of the variables from the dataset itself. So here let's go ahead and proc print the normal data, then we will see how to suppress it. It's just a normal where condition. So we have data like this. So as in this slide, when I was taking you through the slide, I told you that in output listing we used to have data into multiple lines. So this is what happens. Look, 37 37 because it was not able to accommodate the data because the line size and the page size was, but in result output, which is an HTML output, it got auto corrected and the complete report appears as an HTML output. See, okay, let's close this window and then we go to our next program where now this is a time when we have removed customer ID from the where statement and added it to the ID statement. Let's see what it does. We press F3. See, if we see the previous result, we have observation column 76, 74. These are the numbers there. But here our customer ID has become the observation column itself. These are not the observations. The original observation is not intact, but the customer ID column that we have here as the first variable has become the identifying column in this report. Producing the detailed reports, sorting and grouping report data. That's our next section. Our objectives would be to sort the observations in SAS dataset based on the values of one or more variables, display the sorted observation, and display a dataset with reports total and subtotal for each by group. Business scenario we have is that to display the observations from Orient.sales in ascending order by the variable salary. Step 1. We use the sort procedure to create a new dataset work.sales ordering the observations by the value of the salary. Step 2. We use the print procedure to display the sorted dataset work.sales. Let's go ahead and work on these steps. The sort procedure arranges the observations in the input dataset based on the values of the variable or variables listed in the by statement. So proc sort data equals to orient.sales out equals to work.sales by salary. The by statement in proc sort step specifies the sort variable and optionally the sort order. So we have proc sort data equals to any input data set that you want to give, and out equal to option is optional because if you want to sort the original data set, then we do not give out equal to option, and if we don't want to sort the original data set, we want a new data set to be outputted as a sorted data, then we use out equal to option and we give the library ref and the name of the data set. By descending or ascending totally depends on our choice, our scenario that we will have. If you want the particular variable to be ascending or descending, that option can be given here. For ascending, we don't have any option, that is by default. For descending, we have to write descending word before the name of the variable. And for each variable, we have to write separately the word descending. When we view the log and submit the When we submit the program and view the log, the sort procedure does not produce a report. Check the log for errors or warning. So proc sort data equals to orient.sales. So there were these many observations that were read, and the same number of observations were written, and the same number of variables were also written. Viewing the output. To view the output, we must use proc print. So proc print data equals to work.sales, no OBS. We don't want observations column because we are using employee ID as the first column here. Then the second column is last name and then the salary. Then we run. So this is our partial output. Sort procedure. The sort procedure replaces the original data set or creates a new one. It can sort on multiple variables. Sorts in ascending by default or descending order if we specify. And it does not generate printed output. The input dataset is overwritten unless the output equal to option is used to specify an output dataset. Business scenario. Produce a report that lists sales employees grouped by country in descending salary order within the country. So country is the major group and salary is the minor group. So creating a grouped report. Step 1. We use the sort procedure to group the data in a data set. This scenario requires two variables to be sorted, that is country, descending salary within country. We use a by statement in procprint to display the sorted observations grouped by country. So step 1, sort the data set to group the observations. So we are using the original data set as orient.sales and the output data set as work.sales. And first we are sorting the data by country, ascending, and salary would be descending within the country. And when we specify the sort order, the descending option reverses the sort order for the variable that immediately follows it. The observations are sorted from the largest value to the smallest value. So descending last, so last would be having the last name. If Z is the last name, starting of the last name, so it would be starting the last name from Z, and then first name would be sorted ascending. So in the second example, the last name would be ascending and the first name would be descending. And in the very last example, we have the last name would be descending as well as the first name will also be descending. Specifying multiple by variables. So we can use multiple by variables. Proc sort first arranges the dataset by the values of the first by variable, and then proc sort arranges any observations that have the same value of the first by variable by the values of the second by variable. This sorting continues for every specified by variables. Step 2. Specify report groupings. By statement in proc print step specifies the variable or variables to be used to form by group. Proc print data equals to work.sales no OBS by country. The variable in the by statement are called by variables. The observations in the data set must be in order by the variables in the by variable or variables. So the syntax is by, ascending or descending based on our requirement, and then the variable names. And when we see the output, this is what we get. We get a separate report printed for country Australia and separate report get printed for country US. Modify the previous report to display the selected variables, the salary subtotal for each country and salary grand total. So this is the basic requirement. So we want our salary total for Australia and US individually and then their grand total. Generating subtotal. Use a by statement and a sum statement in proc print step. So we use a proc sort data equals to orient.sales out equal to work.sales by country descending salary and then run. And then we print data equals to work.sales no OBS. So that is the printing that we are doing on the output data set, and we are grouping it by country and we are doing the sum of the salary, and we are displaying only the variables first name, last name, gender and salary, and then we are running the program. After we run the program, this is the output that we get: the sum of the salary for Australia, sum of the salary for US, and then the grand total is there. Let's see how sort works. So this is a sort program. Let's go ahead and submit this. When we submit this program, it does not give you any output, but we will check the log if it has sorted. Yes, there were these many observations read from here. The data work.soils has 165 observation and 9 variables. Procedure sort used. That means the data has already been sorted. So let's go ahead and see the output. So for that we will have to use proc print. So again we run the proc print and then we get the output. So this is sorting has happened. We have limited the number of variables. We have suppressed the OBS column. So that's why we have so less number of variables there. Here, if we see the data oriented sales and country, that means salary will be descending where the country would be ascending. So that means AU would be appearing first and then the salary within AU or US would be in descending order. But it will not print as if this has only sorted. Let's check. Yes, this has successfully sorted it as the log says. So we will go back to the program and print our data without any observation, that is work.sales. So see, the country has been sorted. It's AU first and then we have US data appearing, and within AU if we check, the highest salary should appear on top. So 10,000, sorry, 108,000, 87,000, 36,000. It goes in descending, it keeps on descending till the first observation of the next group, that is US. So we have grouped the data, and within this major group the minor group has been sorted, and even the major group is also sorted. 243,190, that is chief sales officer's salary for US. Again it goes descending. See, right? Now if we are just grouping it by country, so it was only single report that displayed both the data together, but in proc print if we use by country any variable name, it groups it with that variable, the values with that distinct values with that variable. So let's go ahead and run this program and check what is the difference in the report as of now. So on the top we have report for Australia. It says country equals to AU, but in the previous one you see US and AU results both were printed in a single report. We did not have a separate report for them, right? So that's the difference in the next report when we group it. So we grouped it by country. So AU result comes first, and within that we have salary as descending, and then we have US, country equals to US, and there we have again salary in descending. Now we want to do the sum of each group and then the grand total of the complete variable, and we also want to limit the number of variables. So we first sort our data by country, and within country again descending salary, and then we are going to print the program. So as we are running the complete program, we need not to select anything. We will just click on submit button and it will give us the result. So first it gave us the total for AU, that is Australia, country equals to Australia, and then it gave us the total for US, and then it gave us the grand total, so which is again same like 5,141,420. This was the same number we have seen when we have used the sum statement. So that is correct. We have the grand total